Okay, today we're going to take a look at statistics part 1. So here's what the curriculum says about statistics from this unit. So there's a couple things. One, we need to look at some of the language that the statistics unit incorporates, including the word bias, and then some other words like population and sample. So as you look through what the curriculum says, I'm not going to read the whole thing to you, but it says things like describe the effect of bias, identify whether it's a population or a sample, and then these words are used in the context of various questions that it's going to ask. Okay, so let's take a look at some of the terminology used in defining statistics. So first of all, the word statistics is a branch of mathematics concerned with the systematic collection and arrangement of large numbers of observations in the way of drawing useful conclusions from the data pulled in from that collection. The power of stats is to add impact and credibility to things like arguments. So for example, rainforests in Peru have been disappearing at a rate of 26% per year. This has impact because of the statistic that has been included. That 26% helps to make your argument stronger. So people who know this are people like politicians, people like advertisers, amongst others that use statistics to help make their point and persuade people. So the word population is the entire set of individuals that we are wishing to study. So for example, all the people living in Canada is the population of Canada. All the students in the school is the population of the school. All the students in this class is the population of this class. A sample is a subset of the population. It's selected to give information about the population as a whole. So the sample should represent the population. So for example, if we took all the grade 9 students in the school, and that's our population, then just this class is a sample of that population. Okay? So simply put, the population is everybody you're studying, and a sample is just a portion of the population. Now this can get a bit tricky because, for example, one sample could be a population for another experiment. So we have to make sure we're all talking about the same thing. So when we choose a sample, one thing we want is some aspect of randomness, but also some aspect of representativeness. So a random sample is when every member of a population has an equal opportunity to be selected within the sample. A random sample should have the same characteristics as the population and therefore becomes an accurate representation of that population. Now, sometimes this is not possible and it's hard to achieve. So what might happen is the data that you derive from a sample might be misleading because it doesn't represent your population. Okay? It might, in fact, only represent a minor portion of your population. If this is true, this is said to have bias within the sample. So a bias is an unwanted influence on a sample that prevents the sample from truly being representative of the population. Okay? The word census is used when you survey an entire population. A survey is a sample of information taken from that population. Other words that you could use when gathering statistics include the word a tally mark and things like that when keeping track of the data being studied. Okay, so if we're going to study data, some techniques that are used to gather the information include a primary data gathering method, which is when you go out and gather your own data. However, if you use someone else's data, for example, something off the internet or something that you pulled out of a textbook, you're using a secondary data gathering method. Okay? When you want to gather data, common techniques include a questionnaire, right? So giving out a questionnaire to people, which will be through an interview or a survey or etc. The problem with this is only people who actually want to answer your questions will respond. And the way you word your questions might actually influence the results that you're trying to gather. Convenience sampling is when you want to check, for example, at the supermarket, is this fruit fresh? You would only maybe grab one or two, say, apples right off the top of the pile because it would be inconvenient for you to dig further down and get an apple off the bottom of the pile. So for convenience, we just sample a few of the apples up on the top. This makes life a little bit easier for us. Systematic sampling is when we select from a list using a interval value, some sort of a number. So for example, every fifth person on the list is going to be sampled. So this gives an element of randomness to it, okay? Stratified random sampling is similar in the sense that first, though, you separate your population into different groups or strata. For example, gender would be an example. So I'm just going to separate the boys and then the girls, and then take every fifth person through a random sampling. And then we have volunteer response sampling, which is basically only those who volunteer will be part of the sample. This has a bias as well because that would maybe only sample out those people who are actually willing to submit data. Okay, so in working with statistics, there's a couple little calculations that you're going to have to do. Okay? For example, the mean, the median, the mode, and working with percentages, which we've done before in this course. So the mean is essentially also called the average. To calculate this, you add all the numbers that you're studying together, come up with a sum, and then divide that sum by how many numbers you had. Okay? The median is the middle number when you arrange your data in order. And the mode is the number that occurs the most within a set of numbers. So let's try this. Here's a set of numbers, okay? A 20, a 20, a 40, a 70, and a 90, okay? These numbers are already in order. We've put them in order from smallest to largest. So when we calculate the mode, it's the number that appears the most often. So in this case, the mode is 20. There's more 20s in the list than any other number. Then the median. The median is the middle number. So when they're arranged in order, we go to the middle. The middle in this case is 40. The average, or the mean, has to be calculated. We add all those numbers together, and there's 5 of them. We get 240, and then we divide by how many numbers there were, which was 5. So 240 divided by 5 gives us 48. So here you can see the mode is 20, the median is 40, and the mean is 48. In this particular list of numbers. A percentage, we know, is basically a number that we can calculate from a fraction, right? So for example, if we had a quiz and we got 47 out of 60 correct, 47 out of 60 is a fraction. If we actually do the division, 47 divided by 60, we're going to get the decimal number 0.78333. Then to turn it into a percentage, just take that decimal and multiply it by 100. So we get 78.3% on that particular test. Okay, so another piece of statistics is taking a look at data and criticizing it, critiquing it. So we're going to look at this in terms of a bar graph. Okay, so a bar graph, like any other graph, has an X and a Y axis. Graphing can be done by you personally creating the graph. It can also be done quite quickly with software, computer software, like for example the program Excel does a really good job at that. So let's take a quick graph. We're going to graph the number of kids in math class, 31, art class, 26, and history, 36 kids. So here's the way the graph could look. Okay, I use software to create this graph. We have a scale that starts at 0 and goes up by tens on the y-axis. So 0, 10, 20, 30, 40. I went up to 40, even though that the highest number was 37, but it gives you a nice sort of zone to put those numbers in. And then we put our 3 courses in there. When you look at this graph, initially it looks like they're very close in numbers. But by just manipulating the scale slightly in the second graph, it looks like there's radically more people in history than in art class. But really, all I've done in this graph is, one, change the scale. So rather than go up by tens like the previous graph did, this graph goes up by 2s, 22, 24, 26. And the other thing I changed about it is in the previous graph, I started my y-axis at 0, so right at 0, and then it goes up from there. Whereas with this graph, I started at 20. So just by making slight changes in the graph, the way we create the graph, can make the graph itself look radically different. And people know this about statistics. People create statistics to influence and make their arguments. So of course they're going to try and make things like graphs look favorable to what they're trying to prove. Okay, let's wrap up with a couple examples. Determine if the following is a sample or a population, and if it's a sample, is it a random sample? The boys in Mr. Wachs's math class were asked if they like watching hockey on Saturday night. This will be used to argue that most grade 9 students like watching hockey on Saturday. Well, this is a sample because it only represents a portion of the grade 9 students. And it's not a random sample because I only surveyed the boys, which means that I had a bias in my sample there, which could influence the outcome of the statistics. Okay, second example. Is there bias in this example? In 1948, before the US presidential election, a telephone poll was conducted to predict, would Harry Truman lose the election? The prediction was that he would lose. However, the prediction turned out to be false. Well, there is bias in this because back in 1948, only a small portion of the population would actually own a telephone. So only those that owned a telephone would be called for the poll. So that's not a very good sample. Doesn't represent the population very well. It has bias in it. Okay? All right, so let's wrap this up. Here are your key concepts for this particular section of statistics. Just some words that you need to know and be familiar with, and be comfortable with them so that you can compare them to what the curriculum is asking you to learn here. All right? And that's statistics, part 1.